This presentation has been produced by Group Number 13, which consists of Jordan Corrigan, Gerard McCoy, Daniel Livesey, Daniel Savage, Bronte Polvani and Matthew Aspinall. During this presentation, we will be researching and analysing the best possible solutions in relation to the 6 key elements to construct our building, which we have decided to name Quayside Tower due to the heritage roots of Salford Quay. Sustainability is a key value for our project team, therefore we will seek to utilise renewable materials and include systems within the building that will reduce energy consumption. I'm Jordan Corrigan and I will be looking at the foundations for Quayside Tower. My slides will initially analyse the different foundation options available and when they should be used, and the advantages and disadvantages of each before concluding with the most suitable foundation for the building. I have been given the following scenario which will impact my decision on the type of foundation that is suitable for building. At 0 to 3 metres, demolition waste has been discovered. 3 to 4.25 metres, coarse sand. 4.2 to 6 metres, stiff brown boulder clay. And 6 to 20 metres, red sandstone bedrock. A water table level was also encountered at level 1.2 metres below ground. This is known to be the highest level that the water table rises to. 4 main types of foundations, which are the strip, pad, raft and pile foundations. Strip foundations. A strip foundation is a type of shallow foundation often used within low to medium rise residential buildings. It's suitable only where the ground conditions are stable and with good load bearing capacity. Strip foundations are fast and cost effective to build. This is the most common foundation used in the UK. The wider base of this type of foundation allows for weight to be spread over a wider area and provides better stability. The building regulations defines a minimum width for strip foundations based on the loads and type of ground conditions. There are several types of strip foundations that can be utilised depending on the project conditions. We have the pad foundations, and these foundations are shallow foundations that take the spread of the point loads to soil safely. The pad foundation is supposed to spread the concentrated load safely to the bearing stratum. Hence, pad foundations must be designed stiff so that uniform spreading of the load to the soil must happen without making the foundation pressure exceed the permissible bearing stress. This requirement is achieved by either reinforcing the pad or making the pad deep. Both the methods help to spread the force in a predefined angle. The angle of spreading is determined based on the bearing capacity of the underlying soil and the concrete strength. The size of the pad must be such that tension needed to prevent within the concrete so that no cracking cause will result in failure. The ability to resist the punching shear is a governing criteria that determines the depth of reinforced concrete pad foundations. Is a raft foundation, and this is a reinforced concrete slab under the whole of a building or extension. Looks like it's floating on the ground as a raft floats on water. This type of foundation spreads the load of the building over a larger area than other foundations, lowering the pressure on the ground. This is an alternative if you can't use the traditional strip or trench fill foundations, but it's important to note that raft foundations aren't suitable in all cases and usually need to be designed by a structural engineer. We have the pile foundations, and these are deep foundations. They're formed by long, slender, columnar elements typically made from steel or reinforced concrete, or even sometimes timber. A foundation is described as a pile foundation when its depth is 3 times its breadth. Pile foundations are principally used to transfer the loads from superstructures through weak compressible strata or water onto stronger, more compact, less compressible and stiffer soil or rock at depth, increasing the effective size of the foundation and resisting horizontal loads. They are typically used for large structures like the one we're going to encounter in this project, and in situations where soil is not suitable to prevent excessive settlement. It's also beneficial to use a pile foundation when the groundwater table is high, as again linking back to the project brief, we do encounter a water table at 1.2 metres. Table that I've produced for each foundation. So taking a look at some of the advantages and disadvantages of each foundation type. So firstly, the strip foundation. It's a commonly used foundation, so the understanding is greater of how to use it, and it's also cheap. But on the disadvantage side, it may require trench support, there's a longer construction period, and ground conditions have to be compatible as not to cause any hazards. A pad foundation is economic. Shallow pad foundations require less excavation, and the size and shape can change depending on the ground conditions. But disadvantage is it cannot take excessive weight, such as a concrete office block, or use on fragile ground, so it's not suitable for this project. A raft foundation can also be economic and can also be utilised as the floor slab. It requires little excavation, it can cope with mixed or poor ground conditions, and it reduces differential settlement. On the other hand, it requires formwork. Edge erosion and cracking can occur if not treated properly, and it's expensive to construct. Lastly, the pile foundation can be prepared ahead of time based on the length. It may be placed across a huge region and very long distances. Precasting shortens the time it takes to complete the project. We can employ heaps in situations where drilling isn't necessary. Unfortunately, when driving through the stones and rocks, a pile is immediately damaged. When the piles are driven, vibrations are produced which can damage the nearby structures. A pile cannot be higher than the earth that it's in, and operating piles necessitates the use of heavy machinery. Different options. I believe that either the pad or power pile foundation would be more suitable option in this instance, as they both will be able to distribute the concrete building loads and will work well with the ground conditions highlighted in the brief. Both the pile and the pad foundation should be able to cope with the demands of the building loads and ground conditions in order to create a strong and stable footing for the building to be erected upon, and I have opted for the pile foundation. This foundation will enable the superstructure to be built upon a pile cap, and the piles will be driven to a depth in order to transfer the load of the structure to the stiff ground beneath with a higher bearing capacity, and it will also combat any soil settlement that may take place due to the water table. It contains my references for completing this presentation.
In this assignment, I will be deciding on the best basement construction method suitable for the new multi-storey site in Salford, which will house a number of private businesses, conference rooms and accommodation for multinational first-year students. The basement amenities are as follows: EV charging points, as people are becoming more conscious of the environment. There are more electric vehicles on the road, which our basement car park will accommodate for. We will also accommodate for ride-sharing apps such as Uber and Lyft, as they've changed the transportation industry. We will provide buffer zones which will provide space for these ride-sharing apps. Our basement car park will cater to all types of automobiles to meet challenges of the diverse vehicles that will be used in the future. We will also include for bike racks, storage areas and plant rooms, which will be dedicated space to contain equipment required to provide or supply building services, for example ventilation, electric distribution and so on. The considerations I have to think about for the different basement waterproofing systems are nature of site, building form, legal issues and economic issues, which I have spoken about in more detail on the slide. This slide shows how the different basement waterproofing grades differ from each other from usage, performance level, humidity, dampness, wetness and temperature. Based on my findings, I've decided to use grade 2 as it provides better utility for retail storage, electrical and plant rooms. No water penetration is what we need, as we'll also have EV chargers and plant rooms in the car park basement. The functional requirement of water below ground are structural stability, durability, moisture exclusion, and buildability, which I've spoken about in more detail. I've also included the ground conditions in which we will be building the building on. There are three main types of waterproofing designs, which are membrane type A, monolithic type B, and drain cavity type C. Firstly, there is type A, which is tank protection, which consists of water-resistant layer in the form of a membrane. This is often installed to the exterior face of the build. Type A construction comes in a wide variety. This type of basement construction relies on the waterproofing membrane because it lacks integral protection against water penetration. Some of the advantages are as follows. It's easy to install, relatively low cost, applied correctly, shouldn't have ongoing maintenance, but some of the disadvantages are potential for puncture of membrane if not installed correctly, and not as effective when used with a high water table or poor drainage. Please see in this slide a description of monolithic basements as well as their advantages and disadvantages. Following my finding of all three types of basement waterproofing approaches, I've decided type A and type C will be incorporated in the design as it provides the best waterproofing protection for varying risks and high water table, which type C is good for, and is the more durable waterproofing system. It is capable of withstanding significant head of water, and if any problems should occur, the systems are accessible for remedial work. The different methods of basement construction I have researched about are shallow/open excavations, top-down and bottom-up approach, and the considerations I have had to think about are listed below. Please see in this slide a description of shallow basement using an open cut approach, as well as the advantages and disadvantages. Please see on this slide the advantages and disadvantages of deep basements. Please see on this slide a description of bottom-up construction, as well as the advantages and disadvantages. Following my findings of basement construction methods, I've decided to use top-down construction as it offers very quick site coverage, which includes a robust working platform. For larger sites, openings can be provided in the floors at many locations with the site and not just around the perimeter. It requires little or no temporary steel shoring, which is good cost savings. It requires no forming for floors or roof, with significant savings in cost and time. Again, it is cheap to construct, and multiple access is made possible through the voids in the slab and not limited to around the perimeter. For combined development that concludes as a substantial structure above ground, the top-down approach makes it possible to get an early start in construction, which is good in this case because the client wants a quick turnaround on the build. For sites of a regular shape, floor slabs are more versatile and therefore more efficient in using steel stuttering. Please see in this slide the description of secant piles as well as its advantages and disadvantages. Please see in this slide a description of contiguous piles as well as its advantages and disadvantages. Following my findings of basement piling methods, I've decided to use steel sheet piling as it is a good resistance to high driving stresses and provides good resistance during installation stresses. It also has excellent water tightness and increased in length and easy adaptability by welding or bolting. It is also connected by interlocking. It is easy to store and lightweight. It has a long service life and can be reused and recycled. Also stronger joints so it can withstand the force of being placed on them. This is why I believe steel sheet piling should be used in the basement car park. Finally, I wanted to speak about what foundation is being used, which is a pile cap foundation which provides the support needed for our structure, as believes it transfers the load to layers of ground conditions that have sufficient bearing capacity and suitable settlement characteristics. Some of the advantages are as follows. It creates stable foundation and offer larger area for the distribution of the building load onto piles. Good weight capacity. It transforms weak soil. It has efficient and is aesthetically pleasing. It is effective almost anywhere and is used to support basements, which is why we think it is a good foundation to be used in the basement.
My name is Daniel Savage and I will be presenting to you structural frame on quayside tower. Ground floor will consist of an open plan floor plate with a reception area, on-site shop, gym and communal areas. First floor will also be an open plan floor plate. This will be for conference rooms. Second floor, 1 and 2 bed apartments. These apartments must comply with Part L, conservation of fuel and power, and Part B, fire safety. The top floor will be meeting spaces. This will be to take advantage of surrounding views. The roof area will consist of a green roof, allowing interaction after meetings. Throughout this presentation, I will be presenting to you material options for the frame being steel, concrete and timber. Firstly, I will be talking about timber frame construction. As you can see, there is a lot more disadvantages compared to advantages in my opinion, especially when considering the 4-story high-rise that we will be talking about in this presentation. The main advantageous point that I will be talking about is low thermal mass. When considering this project, I believe this is most important due to the fact that we need to incorporate Part L of the building regulations. This allows for the construction project to be warmed up and heated efficiently in the burning of fuels. On the other hand, I believe the biggest disadvantage is the design aspect of the project. Due to the fact that timber needs a lot of trusses and vertical members when considering the frame, which can't be allowed within this project. I will be talking about steel frame construction. I believe the biggest advantage in regards to this frame is the prefabrication aspect of the frame. This is done off-site in a non-weather dependent environment, which allows high quality. This is especially important when considering a steel frame due to the fact that welding is incorporated within the design. On the other hand, I believe the biggest disadvantage is the fire resistance of steel due to the fact that it reduces in yield strength rapidly when dealing with fire. This is a massive disadvantage for the end user in case of a fire in the building. The last frame I will be talking about is concrete frame construction. As you can see, there is a high amount of advantages that I consider to be with the concrete frame. In comparison to steel, I believe the most important one is fire and weather resistance. This is especially important when considering a flat roof, which is in the design for the project. It allows for a green roof to be installed, which has been chosen, without having problems of leakage and also fire problems for the end user in case of a fire. On the other hand, I believe the biggest disadvantage is weather dependency, due to the fact that quality can be affected by this largely. In weather such as rain, this can affect the quality a lot and mean that it may need repouring and breaking out as a result. My overall choice for the frame of the quayside tower will be concrete. Why will a concrete frame structure work on the quayside tower? This is due to the fact that we are using a green roof. This allows for waterproofing work to be completed easily due to the fact that we are using an impermeable material in concrete. It also allows for ease of build due to the fact that concrete can take to a large amount of materials that can be used for waterproofing and roofing works. The foundation is being used also piled capped. This allows for a high weight structure to be placed on it, in which we will be using concrete. It allows for ease of construction through the use of the project team. Due to the fact that we're using concrete for the foundations, we anticipate that we will be using the same project team to complete the frame. Due to the fact that we are also using concrete in the foundations, we anticipate that the facilities for the project will include showers in case of health and safety activities such as concrete burns. The concrete frame also includes the regulation requirements for the project, including Part B, fire and safety, and Part L, conservation of fuel and power. We will be ensuring sustainability on the quayside tower through the use of a clear and accurate waste management plan. This will allow for the minimum amount of materials to be wasted and the maximum amount of materials to be recycled throughout the project. We will be using accurate takeoffs done by engineers to ensure that the right amount of materials are ordered. We will also be using an experienced labour level to reduce the chances of components of the frame being done incorrectly and having to be redone. We will also have an accurate delivery plan. This will reduce the chance of materials waiting around and potentially curing up while waiting to go on site. Who will be involved in construction of the concrete frame? Architectural design will be through WSP Design Consultants. The concrete supplier will be Lees Concrete. The concrete fixers will be Renica, and the steelwork reinforcement subcontractor will be CBL Steel Fixers. The design for the concrete frame construction. On the right of the screen, you can see a drawing that we will be using for the construction of the frame. The design consists of columns. These are vertical members which transfer vertical loads, axial or eccentric. Beams, which are horizontal members carrying weight from slab cladding and are supported by columns. Slab, a horizontal plate carrying loads primarily by flexure, carrying vertical loads. Shear walls, large columns carry horizontal and vertical loads. Finally, there is an elevator shaft / stair core that allows for lift or stairs. This helps in resisting horizontal loads and carry vertical weights / loads.
So I'm going to be carrying out the flooring element for the quayside tower as part of our group project. Throughout the PowerPoint, I'm going to be discussing the functional requirements and design considerations I've made when selecting the flooring option. The potential options I considered for the quayside tower are as follows: hollow core concrete flooring, composite metal decking, beam and block flooring, glulam timber flooring, and glass flooring. So for the first one, precast concrete flooring is a highly versatile method of construction used to provide stability and strength under its own weight, with the ability to withhold the weight of imposed loads that may be placed above. The concrete slabs are cured off-site to minimise handling and construction on site, and the support system is usually in the shape of beams, columns and walls, which will support the structure against the different loads, for example the wind loads, snow loads and live loads within the building. Some of the advantages of this are that it has increased building strength, thermal and sound insulation. It's adaptable to multiple building types, for example residential, commercial, hospital and hotels. It's relatively cost effective in comparison to other methods, and it eliminates the need for any formwork or time for concrete to set. And some of the disadvantages are that there's an increased transportation for cost for the precast slabs to be delivered to site, and there's a higher labour requirement for the element of flooring to be built. Beam and block flooring is a technique in which concrete blocks are supported on a series of parallel precast concrete beams. When the blocks are placed in between the beams, it creates a continuous flooring surface. Some of the advantages of this method are that there's a fast construction period, there's a safe working platform, and it's fire resistant, draft proof and rot proof. Some of the disadvantages are that it requires machinery to lift the heavy beams, which can be unsuitable to small developments due to the high cost, and the beam and blocks are manufactured off-site, therefore require a significant preparation time and also a transportation time to get to site. Moving on to the next one, I've talked about composite steel flooring, which is when composite concrete slabs are reinforced using profiled steel decking. The thin sheet of profiled steel is used in the formation of floor in order to create a stronger material. The span of metal decking is dependent on the thickness of flooring profile, the gauge and loading requirements. Some of the advantages of this are its extremely high strength to weight ratio means that the floor has the capability to hold heavy dead loads and live loads. There's also a fast installation of the decking which helps towards a shorter build duration. There's also a reduced cost of the metal deck configuration, allows for steel to be reduced by about 25%, lowering the overall cost of the build. Some of the disadvantages include the difficulties in sourcing the decking in some countries. The cost of importing the steel decking can be high for countries that are not developed enough to manufacture the decking, which can raise the cost for the steel and make it much less cost effective in some countries. The construction team also requires a wealth of experience, as the relatively new method of construction has not been fully adopted as a common method of construction. This makes it increasingly difficult to source an effective labour team to complete the requirements of the job. Moving on to the glulam timber flooring, which is an engineered wood product assembled to precise specifications to create a stable building. It composes of multiple layers of wood lumber bonded together using a high-strength adhesive. Some of the advantages are that it's an eco-friendly material, as timber is a replenishable source. It's capable of creating long supported spans over 500 feet. It's fast and simple installation, leading to a short construction period. Some of the disadvantages of glulam timber flooring are that there's a lower moisture resistance in comparison with concrete and steel, and also a lower fire resistance in comparison to steel and concrete. Walk-on glass panels are an ingenious solution to allowing natural light to flow through a home or commercial building. The glass is fitted with anti-slip grip patterns to avoid any slippages. Some of the advantages of glass flooring are the aesthetics of the glass, giving the building an open and transparent feel, and also the compatibility with other building materials, as well as that is corrosion resistant. Some of the disadvantages include that the glass flooring is heavy and significantly difficult to install, as well as that glass is a highly expensive material with low heat resistance. As you can see from the attached slide, I've created a comparison table which enables me to compare what I thought were the most important factors to the quayside tower, and allow me to get a more effective consideration of what I deemed was going to work effectively, given the design considerations. So the chosen method of flooring for the quayside tower is precast concrete hollow core slab flooring. This is a pre-stressed concrete element that incorporates a continuous void in order to reduce the overall weight of the flooring. Due to the strong nature of concrete, the spans offer an efficient structural section, offering high load-bearing capacities, perfectly incorporating the steel frame being used. Due to the requirements of the building, the concrete is sufficient in holding the load of the first floor gym equipment and office spaces. So some of the design considerations I've made. Due to the uses of the quayside tower and the open plan nature of the building, concrete hollow core allows for the large spans across the building with an integrating heavy load bearing capacity. As well as that, the concrete flooring gives the appropriate fire resistance in accordance with Part B of the fire safety due to the tenanted upper floors. Given that the slabs incorporate a durable soffit ready to accommodate surfaces, this means that a much faster construction period when it comes to the installation of the surfaces. And due to the skeleton steel frame, the concrete slab construction allows for effective collaboration, and the steel frame combining with the hollow core concrete slabs allows for a cost saving, as the tonnage of steel beam required can be reduced by up to 40% in comparison to metal decking. The concrete flooring finish also offers a working platform while the construction is being carried out, therefore other trades can carry out work safely and effectively. As the concrete slabs are cured off-site and delivered already cast, this significantly reduces the construction period as opposed to concrete having to cure in place on site. As a result, the project will be able to see greater cost-saving benefits, enabling a higher profit margin for the project. So the next slide, some of the building regulations I've had to consider. So strength and stability under document A. The structural efficiency of the building is enhanced due to the hollow core design to act compositely with steel beam sections. This means there's no impact of deflection, deformation on any part of the building due to the tower's rigidity. Fire resistance under section B. The hollow concrete floor gives 2 hours Protection, which is 4 times more than timber flooring, which only gives 30 minutes. Concrete is inherently fireproof and absorbs heat from the fire. This in turn cools down the fire and reduces the rate of spread in comparison with other materials. And the resistance to the passage of sound under Section E. Due to the tenanted upper floors, it's important that the hollow core complies with all sound regulations, including impact, airborne and flanking transmissions. So on the slide attached, I've included a section drawing which I've illustrated to show the composition of the steel beam and how it's going to incorporate with the slab flooring I've used. So moving on to the construction method, the steelwork's going to be erected to first splice level above the second floor. Shear studs will be welded to the beams off-site during fabrication of the steel to minimise the amount of time wasted on site. This is also going to reduce any health and safety risks. Edge protection will be established around the perimeter of the building, as well as a fall arrest system, including nets, to comply with all health and safety. A crane is going to be used to assemble the precast units into place using an integrated lifting hook. The units will be assembled in a bottom-up construction method, starting with the first floor and continuing upwards. Grout will be placed between the joints around the floor units and steel columns, and the cement content is going to be 300 kilograms per metre cubed and well compacted into the joints to create a more solid bond. As and when required, transverse reinforcing bars will be positioned into open cores across the internal supports, and U-shaped reinforcing bars will be placed at edge beams to tie the slab into the frame. Pre-welded shear studs are to be used in order to minimise the number of loose debris from the open cores. For the storage and handling on site, close supervision and correct handling of materials is going to be impeccable to ensuring that the offloading, hoisting and fixing of concrete units prevents any potential damage to materials, as this will result in a cost implication on the job. There'll be no stacking of materials on site, as they were delivered in a just-in-time method of delivery in order to reduce the cost of storage on site, as well as the labour in stacking the materials. When material deliveries are made to site, the area in which they're delivered will be firm and level ground, and the precast units are to be delivered using a 4-leg chain to ensure the equal distribution of the load. These are the references I've used in my presentation. Thank you.
My name is Daniel Livesey, and I'm going to be discussing the cladding element for our proposed commercial and residential block, Quayside Tower. There are several functional requirements of cladding, which are that it provides fire resistance, offers sound resistance, it's aesthetically pleasing, it increases the heat gain and reduces the heat loss, it controls internal temperature, provides weather resistance, gives durability, and it gives strength and stability. There are different types of cladding which can be used, some of which are brickwork or stonework, curtain walling, precast concrete panels, insulated render, tile and stone veneer panels, glass and steel facade systems. Firstly, we have the stone cladding. There are several advantages and disadvantages to using this. The advantages are that it is economical, it is durable, there are a wide range of options, it is weather and fire resistant, and it is easily maintained. The disadvantages are that it is labour intensive, it is expensive, it is also prone to trapping moisture, which can lead to bigger problems further down the line. It also requires a suitable structural substrate for installation, which will increase costs of the project. Then we have our metal cladding. The advantages of the metal cladding are that it's durable, there are a wide variety of options for finishes and styles, it's easily maintained, it's a sustainable material, and it offers a good fire resistance. The disadvantages are that it will rust over time and its colour can fade, so if aesthetics is your aim, then it might not be the best choice. It's not cost effective and it doesn't provide sufficient noise resistance in extreme weather conditions. Then we have the curtain wall system. It is aesthetically pleasing, it offers good natural daylight, and it has good energy conservation and energy savings. It's also economical. The disadvantages are that it's not cost effective, there are increased maintenance costs involved, and it is more susceptible to damage. We then have our fibre cement cladding. The advantages are that it is a highly durable product, it's environmentally neutral, and it offers a long lifespan. The disadvantages are that it's not good for insulating, so you will require some additional insulation inside the building. It's an expensive product and it's labour intensive when installing. Then we have timber cladding. The advantages to this are that it is economical, it is a good insulator, it is sustainable, it's easy to repair and maintain, it comes with low maintenance costs, and it is a dynamic product. However, the disadvantages are that it is expensive, although it does have a long lifespan. Materials can become rotten if they're not properly maintained, and it is labour intensive when installing. We then have our precast concrete cladding. The advantages to this are that it does not require on-site construction and can be manufactured off-site. It is quicker to install, it is a highly durable product, and it does come with low maintenance. But the disadvantages to this are that it is difficult to deliver to site due to the sheer volume and the excess of weight, so it will require higher delivery loads. It is expensive, it's probably the least aesthetically pleasing option, and it does come with potential install difficulties. According to Building Regulations Part B, Building Regulations for cladding states that projects that exceed 80 metres in height, installers must achieve a European classification of Class A1 or A2. Previously, cladding materials were subject to older British standard classification. This was superseded by the European classification, which states that building work shall be carried out so that materials which become part of an external wall or specified attachment of a relevant building are of a European classification A2, S1, D0 or A1, classified in accordance with the British Standard EN 13501, 1 2007 and A1 2009. British Standard EN 13501 defines Class A1 and A2 as per the following. Class A1 products are described as having no contribution to fire and will therefore not contribute at any stage of the fire, including the fully developed fire. Class A2 products are described as having no significant contribution to fire and will therefore not significantly contribute to the fire load and the fire growth in a fully developed fire. For our choice of cladding, we've decided to use a curtain wall system. As the frame will be a steel structure, installing a curtain wall system will provide a sufficient strength and has the ability to support its own weight, which will reduce the load-bearing weight onto the foundations. It offers a good resistance to positive and negative wind pressure. Curtain walling is becoming a more preferred option of cladding throughout the construction industry due to its aesthetics and ease of installation compared to other types of cladding. Curtain walling offers good insulation to the building due to the panes being double glazed. It provides good resistance to all kinds of weather. There will be a reflective glazing installed to prevent people from the outside looking in. It also reduces running costs of the building as it provides a very good climatic control. The reason for our choice is due to the purpose of this building. We felt like this was an appropriate selection due to the benefits it provides. As the building has both commercial and residential areas, the system would allow for more natural daylight into the building, reducing the need for using lights during the day. The system offers highly aesthetical features. Glazing is environmentally friendly and has an average recycling rate of 80%. More and more buildings are constructed using glazing systems, so it will not be out of place and will keep up with the aesthetics of modern day construction. Curtain walling is a good insulator and will therefore provide saving to heating costs, and it will also increase the sustainability for our projects. So how is curtain walling installed? The method of installation for curtain walling will be to use curtain wall anchors, which are installed to the pre-stressed concrete slabs. Once the anchors have been installed, a weather-resistant seal is then installed around each of the curtain wall seams. This will provide weather resistance and keep the building airtight. According to building regulations, glazed areas are not classified as fire-resistant areas, so when installing curtain walling, a fire-resistant foam is applied between the glass and the floor to prevent the spread of fire. Finally, a smoke seal is installed to seal the gaps around the glazing and provide that additional protection. Here are my references for the information and the images that I have used.
Quayside Tower Roofing System, both a commercial and residential tower for Salford University by Bronte. Quayside Tower is planned to be a commercial building for Salford University. It is to hold recreational facilities throughout the tower, and so it's important that all the roofing design reflects this. For this reason, I have chosen to construct a flat roofing system to allow for quality functionality, additional rooftop recreation and a unique aesthetic. One flat roofing method is mastic asphalt roofing system. This is a combination of asphalt aggregate, limestone and limestone powder. The mastic asphalt is a waterproofing system that combines with the typical layering of flat roofing arrangement. As demonstrated, this includes the roofing substrate, vapour control layer, sheathing felt, and then the mastic asphalt, which is melted and poured over the sheathing felt and then coated in a solar reflective paint layer. The system is extremely diverse, as several types of roofing products can be used in conjunction. For example, different grades of insulation or distinct types of substrates can be used depending on the proposed structure. The mastic asphalt also has high durability and has been successfully used to provide unbeatable protection from water penetration for over 150 years. However, despite the waterproofing membrane having high durability, other elements of the system may fail over time and require full replacement, implementing the renewal of the waterproofing membrane as this has been melted into place initially. Another limitation of the system is the process extremely labour intensive due to the distinct roles incorporated when layering the membrane. This can be intensified if the roof has restricted access routes. The process produces a lot of smoke due to the constant heating of molten. This pollutes the nearby area, therefore has a negative impact on the environment. As Salford University strives to achieve a strong environmental benefit across the campus, the new commercial construction, Quayside Tower, will not be using the mastic asphalt roofing system. Sheet metal roofing system. Stainless steel, copper and zinc are all metal roofing systems that share similar qualities. They are comprised of sheet-like panels that can be either flat or profiled. Sheet metal roofing is typically connected by standing joints or rolled seams that are clipped at the junction. This is a very flexible system that can be prefabricated or formed on site. One advantage of metal roofing system is the lifespan of materials, with an expectancy to last between 40 and 70 years. They have the durability to withstand all elements, including gusts of wind up to 140 miles per hour. They are also highly energy efficient since metal surfaces reflect heat back into the atmosphere. This reflective property allows a saving of up to 40% in cooling costs in the hot summer months. They are also highly environmentally friendly. Despite the benefits of the metal roofing system, it can be expensive, with just 1 square metre ranging from £10 to £100. The installation of labour can also be expensive due to specialist training, knowledge and equipment required. Additionally, the metal roof can be noisy and project the sound of hard rain and hail throughout the building. This will be a disadvantage for Quayside Tower due to the commercial requirements, such as the conference rooms on the top floor. Another flat roofing method is GRP and fiberglass. This, paired with timber decking, is a strong yet lightweight roofing system and can bear enough weight to allow people to access the roof. Fiberglass roofing includes wetting out the layers of glass mat onto the roof, and when cured, a top coat can be added for extra durability and waterproofing. Like mastic asphalt, the GRP roof is highly durable. This will limit the need to replace the roof on the multi-storey building. However, if it does require repair work and maintenance, the system is simple to repair and, depending on the extent of the repair, can be completed by just one person. Additionally, fiberglass does not gather moss and is easy to clean. One limitation of the system, however, is the cost comparison to other flat roofing methods discussed. The system is also very weather dependent and cannot be installed in wet conditions. Due to the location of Quayside Tower, the GRP roofing system may add unnecessary delays on the project due to the weather. Despite the system being used on larger projects previously, the system was traditionally built for smaller construction, and Quayside Tower may suffer major drawbacks in the system if this is used. A green roof comprises multiple elements to enable vegetation growth and basic functionality. Each layer is described in the diagram below. There are 2 types of green roofing systems: extensive, which contain lightweight vegetation and require little maintenance, or intensive, which consist of heavier vegetation and are high maintenance. Quayside Tower will be a mixture of both. There are many advantages that stem from installing a green roof. They promote biodiversity within urban environments, meaning that wildlife and nature can thrive in alternate areas across the city. Another eco-benefit is that provide thermal efficiency due to the high insulation that green roofs offer. In turn, this will reduce energy costs and the need to heat up and cool down the building will lessen. They can help retention of rainfall as vegetation absorbs the water, reducing the water load on the drainage system and the possibility of flooding. The risks associated with the green roof usually result from poor construction of the system or with incorrect materials that have been used. If installed incorrectly, root penetration can occur where vegetation grows through the structure. This can result in the roof leaking or potentially collapsing. Green roofs are also viewed as an investment due to the costly methodology. They are limited to cheaper alternatives as the system requires quality installation process using quality products. The intensive system used on Quayside Tower will require high maintenance due to the large-scale vegetation incorporated, such as the trees and bushes. Raised timber decking will be incorporated into the design to accommodate the recreational area of the rooftop. The decking will be elevated by stumps that will hold the timber 300 mm above the waterproofing layer of the system. This spacing will hold a shallow tanking system to collect the rainwater that has fallen through the integrated grates of the decking. There will also be a pumping system installed under the decking to pump the collected rainfall into a large storage tank where the water can be filtered and pumped back into the building's water system. The remaining area of the rooftop will be slightly sloped towards internal drainage systems that will be allocated along the access routes across the rooftop. These drainage pipes will also feed into the storage tank to reuse the water. This will collect most of the rainfall due to the quantity across the deck. Due to the depth of vegetation within the green roof, the rainfall in these areas will be retained, causing less stress on the internal drainage system. Along the perimeter of the rooftop will be a 500 mm concrete banding. White cement will be used on the concrete mix to enhance the modern aesthetic of Quayside Tower. The banding will hold a glass parapet barrier and will also define the edging of the curtain wall cladding system and will hold strip lighting on the underside lip of the banding to portray decorative cladding. This will not be confused with the lightning strip that is along the parapet concrete wall to protect the building from lightning strikes. 1500 mm toughened glass balustrade panels will be fixed on top of the banding to create the parapet barrier. The extra height will act as further aesthetic handrail for the visitors. This will give a total parapet height of 2000 mm, which complies with the building regulations in the approved document K, that is 1100 mm. Along the north side of the perimeter will be tall hedging to restrict the view of the visitors to nearby accommodation. This allows privacy for both Quayside Tower visitors and locals. Within the rooftop will be 2 staircases and 2 lifts located either side of the tower that can access each level. A fire break system will be installed to ensure that fire cannot spread throughout the surrounding concrete walls as displayed. An example would be to use the RW45 Rockwool fire barrier. This complies with Document B, Volume 2 of the Building Regulations. Demonstrated below are the building regulations that apply to both previous slides. To create the recreational element of the roof, a terrace bar will be included within the design. The bar will be situated on timber decking and sheltered by a timber frame canopy with a simple metal sheet roof. Surrounding the roof top bar will be different types of seating to encourage recreational use of the terrace. Incorporating a terrace bar on the rooftop of Quayside Tower would add value to the project as every space is being utilised for the building's function. Additionally, the rooftop bar will attract more visitors and in turn will source another method of income for the building. Over time, this feature of the tower will pay for the whole construction and should be viewed as an investment. Another way the rooftop will add value is through the instalment of 10 large solar panels. This will be mounted on the green roof system on the opposite side of the rooftop bar. The energy captured will be converted into electricity to power the machinery used on the rooftop bar. An ambition for Quayside Tower will be for the solar panels to power the whole tower by 2040. Demonstrated below is a proposed plan for Quayside Tower. The vegetation planted within the green roof will comprise of an area of bright and colourful plants to attract bees and wildlife. This area will require little maintenance due to the wilderness of the plant's nature. The second larger area of the green roof will solely be grass. This area will hold the solar panels, and so the grass must be limited as to what length it can grow. In order to maintain the green roof, someone must be employed to host proactive maintenance to keep on top of the vegetation growth. The maintenance plan will include the monitoring of vegetation growth on the roof to remove unsafe weeds and encourage further growth of healthy vegetation. Ensure all access routes or clear from vegetation to enable clear fire escapes and walkways, cleaning of the solar PV to encourage optimal energy absorption, and regular draining inspections to ensure all rainwater is flowing and pumped from the tanking system to prevent overflow and standing water.